Hi everyone, Assalamualaikum. In this video, we will continue with partial derivatives of three variables. Now we look at example 2. Given that fxyz equals to x squared plus y cubed minus 3z squared plus xyz. Find A, fyx and B, fxyz. Okay. First, we look at how to find fyx. Okay. Alright, to find fyx, first we need to find fy. And to find fy, we differentiate from f. Okay. From f equals to x squared plus y cubed minus 3z squared plus xzy. Okay. Alright, so now from f we can find fy. Before that, fy means we differentiate f with respect to y. We treat y as a variable and we treat the other variable xyz as constant. Okay, so to avoid error and easy to differentiate, we can write variable y in different colors and put at the back. Okay, from here. Okay, we rearrange and then we put y at the back. Okay, so it's easy to differentiate. Okay, and after that, from here, alright, now we treat x as a constant. So x squared here is a constant. Okay, and when we differentiate constant, and this one also constant because we treat z as a constant, means that 3z squared is also constant. Okay, and when we differentiate constant, we can imagine now we want to differentiate constant with respect to y. Okay, so the answer equals to 0. Okay, so that's why we get this. Okay, equals to 0. When we differentiate constant x squared and constant 3z squared, it is equals to 0. Okay. And then to differentiate y cubed with respect to y, we just imagine, okay, now we want to differentiate y cubed with respect to y. So using power rule, the answer equals to 3y squared. Okay, so that's why we get this. Okay, and then to differentiate xzy, okay, xz we treat as a constant. Okay, alright, so we just imagine now we want to differentiate constant, let's say 2y with respect to y. So the answer equals to 2. Okay, so when we differentiate constant y, the answer equals to constant. Okay, that's why we get this. And after that, we can simplify, so we get fy equals to 3y squared plus xz, right? So after we find fy, so now we can find fyx. Okay, to find fyx, we differentiate from fy. Okay, so from fy equals to 3y squared plus xz here. Alright, since now we want to differentiate fyx, so we put variable x at the back. Okay, then we can find fyx. Before that, fyx means we differentiate fy with respect to x. Okay, we treat x as a variable. Okay, and then at the same time, we treat the other variable, which is y and z, okay, as constant. Okay, and then from here, when we differentiate 3y squared here, Okay, 3y squared, y we treat as constant. So means that 3y squared equals to constant. Okay, and then to differentiate constant, we just imagine now we want to differentiate constant with respect to x. So the answer equals to 0. Okay, so that's why we get this. Okay, and then we want to differentiate zx. Okay, to differentiate zx with respect to x, we just imagine, let's say we want to differentiate 2x, okay, constant x with respect to x. The answer equals to 2. Okay, so means that when we differentiate constant x, which is zx, the answer equals to constant z. Okay, right, after that, we can simplify. So we get fyz, fyx equals to z. Okay, so now we done find a, fyx, right? Alright, now we continue with b. Okay, find fxyz. Okay, to find fxyz, first we need to find fx. Okay, and to find fx, we differentiate from f. Okay, so from f equals to x squared plus y cubed minus 3z squared plus yzx. Okay, and then we have fx here. After we differentiate f using partial derivative with respect to x, the symbol is fx. So after we differentiate, we get this. Okay, and fx here means we differentiate f with respect to x. We treat x as a variable. So to avoid error and easy to differentiate, we can write variable x in different colors. And then we put variable x at the back. Okay, because we need to separate constant and variable. Okay, and we treat y and z as constants. Okay, and then when we differentiate f with respect to x, we have fx here. Okay, and then y cubed here. Okay, since we treat y as constant, so y cubed is also constant. Okay, and since we treat z as a constant, so 3z squared is also constant. And then when we differentiate constant, we can imagine, let's say we want to differentiate constant with respect to x. Okay, the answer equals to 0. So same goes to y cubed and 3z squared. Okay, these are constant. Okay, means that when we differentiate constant, okay, the answer equals to 0. Okay, and then now we want to differentiate x squared with respect to x. Okay, we imagine we want to differentiate x squared with respect to x. So the answer equals to 2x. We use power rule. Okay, so we get this, right? And then yz here, since we treat y and z as constant, means constant times constant equals to constant. Okay, so to differentiate constant x, so we just imagine, let's say we want to differentiate constant 2x with respect to x. The answer equals to 2. So means that when we differentiate constant x, the answer equals to constant, which is yz, right? And after that, we can simplify, so we get fx equals to 2x plus yz. Okay, alright, after we find fx, now we can find fy. Okay, to find fy, we need to differentiate from fx. Okay, alright, fxy here means we differentiate fx with respect to y. We treat y as a variable. So to avoid error and easy to differentiate, we can write variable y in different colors. Okay, and then we treat x and z as constant. Okay, so from here, when we differentiate to x here is a constant because we treat x as constant. Okay, so constant times 2 equals to constant. Then when we differentiate constant, we can imagine, let's say we want to differentiate any constant with respect to x. The answer equals to 0. So means that when we differentiate constant here, the answer equals to 0. Okay. And after that, z here is constant. Okay. Alright. So we just imagine, let's say we want to differentiate constant times x. Okay. Or let's say we put constant equals to 2. So when we differentiate to x with respect to x, the answer equals to 2. Okay. So same goes here. Okay. When we differentiate constant zy, the answer equals to z. Okay. Then we simplify. So we get fxy equals to 0 plus z equals to z. Now after we find fxy, then we can find fxyz. Okay. To find fxyz, we differentiate from fxy. Okay. From here, we have fxy equals to z. Okay. Now we want to find fxyz. Okay. fxyz means we differentiate fxy with respect to z. We treat z as a variable. Okay. And then at the same time, we treat x and y as constant. But there is no variable x and y here. We just have z here. And z is a variable. So means that when we differentiate z with respect to z, it is equals to 1. Okay. So this is the answer for f, x, y, z, which is equals to 1. Alright.
Coming up next, total differentials. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.